Okay, so I'm looking at 2015 here, question 2. So firstly, describe the appearance of phenylmethanol at room temperature. It's colourless. Then you're asked to state the colour change when phenylmethanol was gently heated with potassium permanganate solution to which sodium carbonate had been added. So potassium permanganate is always a purple colour. Again, not in acidic conditions, so my intermediate oxidation state of +4 occurs, giving my brown precipitate. Then you're asked, identify A and B in the reaction scheme that were allowed to the separation of benzoic acid from the other substances after it was complete. So I'm just going to move us over here to A here first. Okay, so we're looking here. This is after I have heated my potassium permanganate, my sodium carbonate, and my phenylmethanol. And then I added in something here, A, in order to make this solution here, my benzoic acid. And what I've added is hydrochloric acid. Okay, so A is hydrochloric acid. All right, and that creates my acidic conditions here. Then if I look here, in order for it to go from the +4 to the +2, I add in sodium sulfite. Okay. So next then we're asked, so that's A and B. Okay, so next then we're asked, what changes were observed in the reaction vessel on the addition of these two chemicals and as cooling occurred? So firstly, what we notice is that the brown colour, that is from the Mn+4, changes to colourless because now with the addition of the HCl I've created the acidic conditions, and then by adding in the sodium sulfite I've also changed the Mn+4 into the Mn+2, so it changes to colourless. Okay, and once you do that, and again once you add in the sulfite, you'll notice my white crystals forming, and remember this then is my benzoic acid. Then you're asked to state the changes of manganese during this. Okay, so Mn+7 is when it's at purple, Mn+4 is when it goes to brown, and Mn+2 is when it goes to colourless. So there are your changes. Part C. After isolation by filtration, the benzoic crystals are purified by recrystallization. So then you're just asked to state one way of maximizing the yield of recrystallization. So we've loads of ones here, and we'd have done this in our experiments. So use minimum, and this would even have been something you'd have done in your junior cert, in the old junior cert, amount of hot water. Okay, so at the very start, place an ice. Okay, again that promotes crystallization. Remember, crystals form when a hot saturated solution is allowed to cool. Okay, the melting range of the benzoic acid before recrystallization was 112 to 118. How would recrystallization have affected the melting point range? Okay, so the range will be narrower and it will be closer to its actual boiling point of 121 degrees Celsius. Then part D, again, stoichiometry, and I've done this. And again, any problems, let me know.